Hope you all are able to hear me.
Yes, ma'am.
Okay. Can I have your videos on, please?
Yes, ma'am.
One.
No, ma'am.
Hello, Abraham. Yes.
Ma'am,
Yeah.
I won't be able to do my science test, ma'am.
Okay, what happened now?
Ma'am, can you repeat?
I'm saying what happened? Why not?
Ma'am, I have an assignment, ma'am. I have to finish it in the next 2 days, ma'am. And because of that, ma'am, I won't be able to do the science test, ma'am.
You have an assignment.
Yes, ma'am. I just came to know this about when I just submitted my when I went to submit my Unit 2 exams.
Okay. Um, okay. So can you submit the test by Wednesday?
Ma'am, can I submit it on Wednesday?
Yes. This time you can submit on Wednesday, okay? This
Thank
time you can submit on Wednesday. But Emma, you please submit me by tomorrow. Okay?
Yes, ma'am.
Yeah. I'll send it today. And Abraham can submit by Wednesday. But Abraham, please make sure that it shouldn't be delayed more than Wednesday.
Okay, ma'am.
Okay? Shouldn't be delayed more than Wednesday. Okay, 1 second. Today Joshua is not joining, he's unwell. So I think we have to start a new lesson. We'll do that. We finished circle chapter. Now. This next we are going to start the next lesson. That is congruent and symmetrical figures. Okay, congruent and symmetric figures.
I'm just going to the washroom.
Yeah, come back first.
Ma'am, do we have to write whatever you're gonna write right now?
I'll give you time to write. Okay, I'll give you time to write. Okay, now there are some figures. Okay, there are some figures that we can fold along a line. Okay, we can fold along a line in such a way that it covers the other part completely. Okay, in such a way that it covers the other part completely. Okay, like this, it covers the other part completely when we fold it um along a line. Those are known as symmetric figures. Those are known as symmetric figures. For example, I have a rectangle. Okay, I pass a line. I will pass a line from here. Okay, I will pass a line, straight line from here. Now, if I fold this rectangle like this, if I fold this rectangle like this, will I be able to say that it covers the entire part? Okay. How? How? See, suppose let's name them. Let's name this part A part and this B part. Okay. If I fold A part over B part like this, okay. If I fold A part over B part like this, will I be able to cover the entire B part? Yes. Okay. Because A and B part are equal. Okay. So when I will fold it along a line, it will entirely cover the other part. This is known as symmetry. Okay. Or this is known as a symmetric figure. This is known as a symmetric figure. Or if we take any other shape, okay. If we take any other shape, say if I take this shape, if I take this shape, okay, and then I fold it along this line. I fold it along this line. Okay, from here I will fold it like this, like this. Okay, like this I'll fold it. So then what happens? What happens? This part will be able to cover the other part. Okay, if I fold it like this, okay, this part will be able to cover the other part. Okay, along a line, along a line. So this is what is known as symmetry. Okay, this is what is known as symmetry. Okay, this line is known as line of symmetry, and these figures which can be folded along a line are known as symmetric figures. Are known as symmetric figures. Okay, I want to show you something. Okay, can you see this piece of rectangle in my hand? Can you see this? Suppose, yes, suppose I have this line of symmetry passing through this point. Okay, passing through this point. And when I fold it along the line of symmetry, okay, let's make your line of symmetry. One second. Now, can you see the line? Yeah. If I fold this along this line, okay, if I fold it along this line, can you see that it is exactly a square? The two parts, see, the upper part is exactly covering the bottom part. Yeah, the upper part is exactly covering the bottom part. Okay, this is symmetrical figures. These are symmetric figures. Okay, now write down the definition of symmetric figures. Write this down. Then writing.
And ma'am.
Hmm. Am I done?
Yes.
Okay. Now, this was about symmetric figures. Okay. Now, what if I have two shapes, okay, which are the same size? When you place them upon each other, they are, it completely covers the other one. Okay. Then you have two shapes like this. Okay. When you have two shapes like this, okay, that when you place one on the other, it completely covers that one. Okay. Completely covers the other one. This is known as congruent. Okay. This is known as congruent figures. Okay. When it completely covers the other figure. Okay. Now this can be any shape. Okay. But when it is put on the other one. Okay. When it is put on the other one, it completely covers it. Okay. It completely covers it. This is known as congruent figures or congruency. Okay. Now, there is this method, okay, like when we are finding if you want to know that a figure is congruent to other figure, like or not. Okay. So what we do, we take this figure and place it on the other one. This method of examining congruency, okay, this method of examining congruency is known as the method of superposition. The method of superposition. Okay, I'm writing it down. When two figures completely cover each other, When one of them is placed on top of the other, on the other. It's called this method of examining congruency is called superposition method or method of superposition. Method of superpositions. Now, there is a symbol, okay? There is a symbol. To represent congruency, it looks like this. If you want to show that two figures are congruent, okay? For example, if I name them circle A and circle B and name these two circle P and this diamond P and Q, okay, or quadrilateral P and Q, and I want to show that these are congruent. So what will I do? A, put n equals to sign and a wave is congruent to B, okay, and here in PQ, quadrilateral P, put n equals to and a wave like this, okay, equals to sign and a wave congruent to Q. So congruency symbol is like this. You put n equals to sign and a wave. This symbol is put to show that two figures are congruent to each other. Understood? This is the symbol for that. Okay, this is the congruency symbol. Please write this down. Make the symbol.
Batman.
Done. Okay, Abraham, done.
No, I'm almost.
Okay.
Yes, ma'am, done.
Okay. Okay. Now, in this chapter, the shape that is particularly talked of is a triangle. Okay. And we have some rules through which we can decide that a triangle is congruent to another triangle. Okay. A triangle is congruent to another triangle. Okay. So we will talk about that. Rules to check the congruency of a triangle. Okay. Rules to check the congruency of a
Ma'am, there
triangle.
are separate rules for each shape.
There are separate rules for each shape. No, we have particularly triangles.
Okay, ma'am.
Okay, we have only triangle in this lesson, and then we have symmetry. Okay, in detail, symmetry in depth. First, we'll talk about congruency of a triangle. Okay, and then we will talk about symmetry. Okay, now tell me, that suppose I have two triangles. Okay. I have these two triangles. Okay. Now tell me that if I tell you ki, why do you think or how do you think can these triangles be congruent? Do you have any reasons? Do you have any reasons?
Yes, ma'am.
If you were to overlap them, then if you
Number one, the angles of all the triangle have to be the same.
Okay. Mm-hmm.
And most importantly, the length of the sides have to be the same.
Yes, the length of the sides have to be the same and angles also have to match. Okay, these are the rules. Okay, and when the sides and angles match, then they will be, like Anna said, they'll overlap each other. Okay, they'll be congruent. Now, based on this, we have rules. Okay, based on what you all said, we have rules. The first rule says side, side, side congruency rule. Okay, or SSS congruency rule. Okay, side, side, side. SSS congruency rule. This rule says that the three sides of one triangle are equal to the three corresponding sides of other triangle. Just give me a minute, please. Okay, I'm back. 1 second. Can you see me?
Yes, ma'am.
Okay. Now, we were talking about side rule, which says that three sides of a triangle are equal to the other three corresponding sides of another triangle. What's the meaning of this? Let's see. Suppose this triangle name is A, P, C. This is my P, Q, R. Okay. Now, AB is suppose 4 centimeter, AC is 4, BC is 3. BC is 3. Now, if in the other triangle that is PQR, okay, which side is looks like in the same place as AB, PQ. PQ is in the same place as AB. So PQ should also be 4. AC should, the side which is like AC is PR should also be 4, and QR, which is base like BC, should be 3. Okay, should be 3. Now, this is where your triangle will be congruent according to the side rule. Okay, what if this is 4? What if this is 4 and this is 3? Not congruent. Okay, not congruent. Why? Because the corresponding sides are not equal. Sides are equal, okay, 4, 4, and 3, and 4, 4, and 3. But corresponding sides are not equal. It should be that this should be 4, this should be 4, and this has to be 3 only. Then only
It
your
was,
triangle.
ma'am.
Yes, Em.
But
Yeah.
if what you are saying is that PR is 3 and QR is 4, we can
Hmm.
just flip it so that it will become right.
No, we cannot flip it. Okay? We cannot flip it. It just means that it will not be congruent because the corresponding sides are not equal. Okay?
Okay.
Because the corresponding sides are not equal. Now, I'll show you one more example. Okay? I'll show you one more example. Take a look at this triangle. Okay? What type of triangle is it, Abraham?
Scalene.
Scalene triangle. Very good. It is a scalene triangle. Okay. Now, in my scalene triangle, look at ABC. Look at my triangle ABC. AB is 7 centimeter. Okay. BC is 5 centimeter. AC is 4 centimeter. Okay. Now, AB and PQ. AB and PQ are corresponding sides. The same ones. Okay. So PQ has to be 7. Okay, BC and QR are corresponding sides. QR has to be 5, and AC and PR has to be 4. Only then will these triangles be congruent according to the side rule. Okay, if PR is 3 even, if even PR is 3, okay, not congruent. Not congruent. Then when you overlap it, suppose I'll overlap it. Okay, see PQ is look on triangle ABC. Okay, look on triangle ABC. If I overlap it, if I place this triangle here, okay, I'm using red to overlap. Okay, PQ on AB. Okay, same size 7. Okay, QR on BC, I will put same size 5. But when I put PR, which is 3, on AC, which is 4, it will look like this. it will look like this. Okay, it will not overlap. It will not overlap. If even one side is smaller, it will not overlap. So it has to be equal. The corresponding sides have to be equal for it to be congruent to each other. Write down if in any two triangles three sides of one triangle are equal to three corresponding sides of the other triangle. Then the two triangles are congruent. Congruent by SSS or side rule. Okay, by side rule. We have three rules and more. For right triangle, we have a different rule. Okay. For normal triangles, we have SSS, side. Then we have SAS, side angle side rule. ASA, angle side angle rule. Okay. For right angle triangles, we have RHS congruency rule. That is right angle hypotenuse side. Right angle hypotenuse side rule. Okay. So I'll do all these rules with you and then we will do symmetry. Okay. And we'll do symmetry. Tomorrow we will do the SAS and ASA rules. Okay.
Done, ma'am.
Done, ma'am.
Okay. So 9:30, I'll share the paper. Okay. You saw that I sent the diagrams, right?
Yeah.
Prepare it. Prepare it. Okay. Emma, your deadline is Tuesday. Abraham, yours is Wednesday. Okay. Both the papers, one paper I need tomorrow, one paper I need Wednesday. Okay. Okay. So we will stop here for today. Okay. Homework. Let me see. Okay. No homework for today. Okay. First we'll finish the rules and then I'll give you the homework. Okay.
Okay, ma'am.
So I'll see you all tomorrow.
Okay, ma'am. Ma'am,
I'll say
so I have to send the test by tomorrow evening, right?
yes, Emma. By tomorrow evening. Abraham, Wednesday evening.
Yeah.
Okay.
Bye, ma'am. Thank you, ma'am.
Okay. Bye.
Bye,
Have a good
Abraham.
day.
Bye, Abraham. Bye, ma'am.
Bye.
Bye.
Mm.